Welcome once again to a new lecture in which we will discuss sensors and actuators. As was previously mentioned, sensors and actuators are part of the BMS layer's field level. So let's get started. Sensors and actuators are simple components that have a far-reaching impact on industrial systems. They often work together to automate and streamline industrial processes such as facility management and manufacturing. But they can also help you prevent equipment failures and extend the life of your assets. So, what are sensors? A sensor is an electrical instrument that monitors and measures physical aspects of an environment and sends an electrical signal to a control center when certain predetermined conditions are detected. It turns physical inputs into electrical signals that are output to the control center. And they can monitor the health of equipment or the status of a sensitive environment. Physical inputs are the following. It can be heat, light, motion, pressure, or any number of other environmental phenomena. What about the actuators? If sensors turn a physical input into an electrical output, the actuators do the opposite. They take electrical signals from control modules and turn them into physical outputs. They can perform a wide range of functions, from turning rotors and valves to virtually anything else. You can program them to control almost any action required. A good example of an actuator is a shut-off valve. It closes the valve when it gets a signal from a sensor or control module. An electrical signal is sent into the actuator, which converts it into a physical action. Sensors and actuators often work in tandem, but they are essentially opposite devices. A sensor monitors conditions and signals when changes occur, while actuator receives a signal and performs an action, often in the form of movement in mechanical machine. Another key difference is their location within the system. Sensors are placed at input points in the system, while actuators are placed at the output point. Looking at the image, we can see a level sensor, which functions similarly to the sensors we discussed earlier in monitoring a signal. As a result, when the liquid inside the tank reaches the sensor, right here, the sensor will be activated and a signal will be transmitted to the controller. What signal will then be sent to the controller? Because level sensor only handle high or low circumstances, the input signal will be a digital input signal. So the controller will receive a digital input signal from the level sensor. Then it will execute an output signal to the valve actuator to close it. So our output signal will be digital output, because our instruction for the valve will be open or close only, meaning high and low also. So it's a digital output signal. As you can see, sensors monitor and measure physical aspects of an environment and send signal to the controller. And actuator take the electrical signal coming from the controller and turn it into physical output. Another thing to be considered in using sensor is the signal type. Signals can be categorized into two types, analog and digital. Analog signal have a sinusoidal waveform. Sinusoidal alternating waveforms are time-varying periodic waveforms with parameters including voltage and frequency. Analog signals are continuous signals, meaning they are time-varying signals that reflect a quantity that changes over time. When you look at the analog signal graph, you'll see a continuous plot with a defined value at each time point. Temperature sensor and pressure sensors are some of examples for analog sensors. For digital signal, it represents data as a sequence of discrete values. It can only take on one of an infinite number of values at any given time. Digital signals are discrete signals with only two possible values, high and low, or 1 and 0. When you look at the digital signal graph, you'll observe a square wave that varies between 2 points and doesn't take any other value. A digital signal is a binary signal that can only take one of two values. And for digital sensor example are pressure switch and flow switch.